So we're going to walk you through what is switchboard, and then what is the decentralized identity angle we take, and then why we think DidWebS, why I personally like it, and why we have migrated as one of the options for our users to DidWebS and Carry. So quick background on the music industry for anyone who's not familiar with it. You can divide the music industry in two. There is what's known as music publishing. Think of songwriters who write songs, so sheet music and lyrics and arrangement. That's usually owned by music publishers. That goes back to the early 1900s. Publishers are the ones who go out and license those songs into other media, including getting recordings of them. So that takes us to the other side of the music industry. It's the recorded music industry. That's usually recording artists, recording versions of songs, compositions. So those create a separate copyright known as a sound recording. The sound recording is usually owned and administered, so licensed by record companies. So a lot of music companies have both operations, but they are distinct. We, in this first product, are solely focused on the left side, so music publishing. So songwriters who write compositions that are then usually owned and administered by music publishers. The process of doing that is very chaotic, and moving metadata and legal identity information around the supply chain is done through unstructured, untrustworthy channels. So you have one or more songwriters. These days in pop and hip hop and country, songs can be written by up to 5 to 10 different people. Each of them, those 5 to 10 different people may be signed to different music publishers. So there's a lot of communication overhead in telling everyone who needs to know who did what. And it looks a lot like this. So it's a lot of text messages, emails, phone calls, a lot of manual data entry. Once that kind of happens and the data gets from out in the field where music is made into, say, music publishers, then you got to kind of run this rights management gauntlet and get that unstructured data into one or many catalog management systems. From there, it needs to go from the catalog management system to one or many distributors, which then goes to one or many intermediaries like licensing, collective licensing organizations. So each of these steps, everyone needs the same data, but it's all different data formats and different database standards. So the process, that's a very difficult process. It results in a lot of lost money and incorrect metadata, legal rights. Everything's a bit of a mess. So music industry, you've probably heard about it. You've probably seen it in the news. It's very inefficient. There's also a lot of identifiers in the music industry. The music industry lacks a coherent identity system. Each of these identifiers is usually associated with a downstream database and how you get paid as an individual, as an organization, or as a copyright, a composition or sound recording itself. So there are different standard identifiers, some of which are ISO standards, some of them are private, but all of these identifiers need to get into the databases in the supply chain. And there's no easy way to do that. It's often manual data entry. And so when one number gets entered wrong, someone's getting paid wrong. The music industry looks like this. If you look at it with X-ray vision, it is a giant legal network. And what are the nodes in the network that connect the actors in the system? It is the legal contracts. So these are all the legal contracts that route data and money around the supply chain, if you were to look at it at a pure X-ray vision. In theory, legal and identity are totally separate. You know, you have legal contracts and then you have identity and all those identifiers. In reality, they're totally blended, meaning the authority to do things in any supply chain based industry, but certainly music, is derived from both. It's, are you who you say you are, meaning the organization or individual and all your identifiers, and can you do what you say you can do, which is usually always derived from a legal contract. So this is what we're really dealing with, this knotted mess. And so instead of fighting it, I for years have said embrace that. So that's what I was just saying. These are the two questions the music industry cannot answer. It's very, very hard for the music industry to answer these two questions. So you're all identity people. You think in terms of these concepts, authentication, authorization. I tend to explain this stuff to the music industry in terms of music identity, and legal authority, and it clicks. The light bulb goes off faster. So what we enable at Switchboard is the ability for people to prove legal relationships that are stuck in paper-based contracts. We then let those relationships define like the state of the copyright, because the legal contracts are going to dictate what the copyright is as far as who owns what and who has the right to do what. And then we create processes to push that trusted, verifiable data into all these different databases by converting between data formats and database standards. So what we did for this first product is we take solely music publishing. So songwriters write songs out in the world, and they usually document their relationship. So one or many songwriters have a legal relationship between each other. That's usually documented in a contract that's informally called a split sheet. Basically says, hey, the four of us wrote a song, we each own 25%. Or maybe the four of us wrote a song, one person owns 70, the other person owned 10, 10, 10. Then we model the relationship between those songwriters and music publishers. That's in a songwriter agreement. Then we model the relationship between music publishers and what are known as administrators. They're the ones who actually do the back end stuff that a lot of publishers don't want to do, including licensing and accounting and royalty management. So this supply chain of legal contracts is how data and money flow into the music supply chain from the original source of creation. And this is solely music publishing. So our basic setup is everyone has originally did web dids. So you can see here, my full identity has a did web did that can be resolved. I have credentials from my music publisher. So this is a songwriter credential right here that models the relationship in my songwriter agreement. So it might be for the next year, every song I write is going to be 100% owned by Steamroller Publishing. That's a common fact pattern in the music industry. Steamroller may have an administrative relationship with a publishing administrator. That is represented in an administration agreement. So we model that as an administrator credential. And again, modeling that relationship so that things I do out in the field will just, all the data, the identity data, the legal relationships, the legal information flows sort of from me to Steamroller to the administrator, and then we can push into everyone's catalog management system. So that's a background, I think, from here. Oh, then this is the final part of this first product we made. We have what we call a workspace. This is a collaborative environment where if your digital identity has permission, you can enter and do things. In this case, it is document a song. So between me and Bob, what's our ownership? We can drop in the lyrics. Everything that's normally texted or emailed from out in the field into a music publisher and a publishing administrator, we're able to model it. We create a split sheet from this. This has structured data model behind it. We then use that to create a composition identity with its own unique did web did. And then from there, that's how we're able to push machine readable data into the supply chain. We call it trusted data because you've got digital signatures from the DID framework. So that's Switchboard. I guess, Lance, you want me to just click through as you talk, or do you want to take control?
Well, that would be great if you could click through.
Okay, cool.
Thank you. Okay, so we're just going to give a quick highlight of DidWebS in 7 easy steps. This is based originally on a presentation that Drummond, Marcus Sabadello, and I did 2 IAWs ago in Mountain View, and then also the presentation that we did with Switchboard at the previous IAW. So hopefully this just gives a high-level view and understanding of some of the benefits and features of DidWebS. Next slide. Okay, so one of the key elements of this is that DidWeb is familiar. It's familiar in 2 ways. If you're from a DID-based ecosystem, then it is DidWeb is a DID, and so that's interesting to you. And then if you're from a web ecosystem, obviously the web is also familiar to you. Okay, next slide.
Oops.
That's okay. Okay, so this is what a DidWeb did looks like. You have from the top left there, didwebexample.com Alice, and what that resolves to is a did.json file, and then down at the bottom right corner, you can see that resolves in a did document that essentially lists the identifier, the verification method, so that you can know the keys that are used to control that DID, as well as services that are available related to the DID. Okay, next slide. DID-WebS identifiers are fully backwards compatible to DID-Web identifiers. This was a huge requirement that we did as part of the DID-WebS specification task force. And yeah, essentially, if you have an ecosystem that's using DID-Web, we would want you to be able to use DID-WebS in a completely backwards compatible way. And hopefully you see that kind of as part of this switch cord presentation that we're doing. Okay, next slide. Okay, number two is that DID-Web trusts the web. There are benefits and drawbacks to that, but that's what we should acknowledge, that DID-Web trusts the web. Okay, next slide. So again, the same slide as before. What's new here is in that upper right, you can see that as part of the DID resolution process and the retrieval of the DID document, what you are using in order to secure these communications is classic web technology. So there's a DNS lookup. There's an X50, there could be X509 certs involved, and you're doing an HTTP GET. So hopefully that all looks, fairly classic in terms of web architecture. Okay, next slide. So benefit two, DID-Web inherits all of the strengths and weaknesses of the web. I think we've all lived with those strengths and weaknesses, over the last 25 years or so. DID-WebS leverages the strengths, which if I was going to leave you with a term, it would be discoverability, right? The web is very good for discovering information. So DID-WebS leverages the strengths of discoverability, but also fixes the weaknesses, and that would be security and identity. Okay, next slide. So number three that we like to get across is that DID-Web and DID-WebS are familiar. Because DID-WebS is backwards compatible to DID-Web, it still feels just like what you're used to with a DID-based ecosystem, and it feels just like what you're used to in a DID-Web ecosystem. Okay, next slide. So this is the only modification here now to this slide. This is the third time we're kind of viewing this slide, but in that upper right-hand corner, you can see an extra line there. We get an extra artifact as part of DID-WebS. So not just the Alice did.json, which is the DID document, you also get this carry.caesar stream. And that carry.caesar stream, if you were from the carry ecosystem, that would seem familiar, but that is essentially what's used in order to transfer, we'll say, the security properties from being a web-based security system to a carry-based security system. And carry is essentially a first principles set of protocols and implementations that is specifically designed to address not just the weaknesses of the web, but weaknesses of digital architecture in general. So, we often in the carry ecosystem talk about all the different kinds of attacks that are leveraged currently by hackers, and we'll just say hackers. We'll leave it at that. And so yes, the carry ecosystem is this first principles security ecosystem, but now that's being combined with this kind of more familiar DID-Web ecosystem to produce DID-WebS. Okay, next slide. So DID-WebS applies carry from the point of view of the web and DIDs, but you can start using DID-WebS without knowing all of carry. That was another important part of the DID-WebS specification group, that we very much wanted to make it so that you didn't have to kind of understand everything about carry, because it's quite involved. If you've looked at the carry protocols or things like that, well, let's just say first principles security takes quite a bit of knowledge and quite a bit of thought and specification. So the important point here is you can use DID-WebS without knowing all of uh, all of those properties and understanding the full ecosystem of carry. Okay, next slide. So number 4 is that did WebS trusts cryptography. So if you remember, it said previously for did web, it said that it trusts the web. Did WebS trusts cryptography, and that's because we are utilizing carry for trust, for establishing trust. Okay, next slide. The identifier syntax is used just like in did-web. So this was an example did-web-s identifier that Marcus used in about a year ago at IAW. And so you can see it's the method specific prefix is did-web-s. And then he has the namespace here, peacekeeper.github.io. He actually had posted this onto GitHub. And then kind of that underlined piece that's at the top, but kind of underneath there, that cryptographic string, that is a carry AID. And that's what allows cryptographic control to be applied for this identifier. So yes, it notes there that the last path segment is a carry autonomous identifier, which we call an AID. And so trust lies in entropy and cryptography. We have what's called key event logs in carry, which you can think of as like a micro ledger or a mini blockchain, if you will. But that blockchain is specific only to the user and their identifier. It allows for this concept of pre-rotation. This is one of the great innovations of carry that allows you to transfer key state over time. So you have persistent identifiers that can last much longer than any of us. Just to kind of give a side note, I work for Glyph, and so our focus is secure organizational identity. If you have an organization, let's say like Coca-Cola, they have an LEI, that's a Glyph administered identifier, a legal entity identifier. And so the kind of software and cryptographic implementation of that is the VLEI, the verifiable legal entity identifier. And it's very important that the identifier that, let's say Coca-Cola, if they have a VLEI, that identifier needs to be able to persist long beyond key state changes, let's say with CEOs or board members or whoever it is. This identifier needs to be able to persist. And so pre-rotation is one of these key elements that allows for the transfer of key state over time with this persistent identifier remaining the same. Multi-sig is also a very important part, and that's basically just means that you can have multiple keys controlling an identifier. And yeah, hopefully that makes sense in an organization, especially. It's not just controlled by one person or one set key. There would be many of them involved. There's this concept of delegation, which I won't get too much into, but essentially we have identifier delegation and verifiable credential delegation. And so that allows us to scale and do quite a few important security operations. It's really important to note that it only uses vanilla cryptography. So nothing crazy new in cryptography has been invented as for carry. In fact, it's cryptographically agile, meaning you could use kind of your favorite, signature-based algorithms and things like that. And then we have a concept of keys at the edge, which just means that truly the user controls their keys, their identifiers. They don't have any other service that they must rely on. Okay, next slide. Okay, so benefit 4 is carry is a first of principles approach to identity with security first. And so that's why we're leveraging it for did-web-s. Okay, next. Did-web-s is a more discoverable carry. So now if you're from the carry side and you say, well, all of these carry AIDs, they're really great. They're these cryptographic strings and they tie to a key event log. And, now I have all these wonderful properties for an identifier. Well, the question is, how do you discover these identifiers? And that's why the web is so useful. Discovery is what the web is excellent at. And so this marriage between carry and did web to produce did WebS is allowing us to leverage the strengths of both sides. So that's a carry AID that you can see. Now note that because that cryptographic identifier is what really gives you control over an identifier, you can essentially have a did carry with that identifier or a did WebS with that identifier. That identifier is unique, that AID is unique. And so you can kind of namespace it with multiple even types of carry integrated did methods. And so, yeah, down at the bottom there, web discoverable carry-based dids are did WebS dids. And yeah, you can still see that underlying portion is the same AID. Okay, next slide. All right, benefit number 5, discovering carry identifiers from the web is easy. Okay, next. Number 6, did WebS is a more secure did web. So if it's backwards compatible to did web, but then leverages carry in order to validate key state and the did document, then now we have a more secure did web. Next. And so in this diagram, I won't go over too much. What you have over to the right there is kind of a classic look at some of carry, key event messages, and things like that. Over on the left side there, you can see that's a did WebS example, and it has a did doc and a carry Caesar file. That carry Caesar file essentially takes you over to the right for the carry stack, whereas the did.json takes you to the bottom there. And that mostly looks familiar to you, or actually should look very familiar to you if you're used to like a did web, did document. And in that case, it's showing your public key, JWK, that it's type JSON web key. That's the verification method, for this identifier. And so hopefully all of that looks classic to you. Okay. Next, thanks. Did WebS did documents are verified against the underlying carry identifier, key state, etc. That's kind of the core of all of this that secures this, is that you will be able to trust the did document that you're looking at because it has been secured by the carry identifier, key state, etc. underneath. Okay, next. All right, number 7 is that did WebS also adds some bonus features to did web. I'll go through these really quickly. Next slide. What you can see here is a multi-sig did WebS did document. You also have this also known as field there, which is showing you other dids that would resolve to the same key state. So for instance, this is a did WebS did document, but note that you can also know this thing as did web. So you could resolve it just as a did web did document if you didn't care about all the security principles and you just wanted to resolve it as a did web, you could. Also, if you are from the did carry ecosystem, because that AID is the same across both, you automatically know you could resolve this as did carry and that AID. So hopefully you can see an ecosystem there of dids that are related because of the AID. And then, yeah, this conditional proof 2022. So in the did ecosystem, a lot of times, if you're familiar with a lot of the did methods, they kind of never even touch multi-sig, whereas multi-sig is, absolutely necessary for the use cases that we have for carry and in the VLEI ecosystem and things like that, secure organizational identity, essentially. And so that condition threshold with kind of multiple keys controlling an identifier, yeah, it's very important. So you start to get into this world of secure organizational identity or multi-sig dids. And so, yeah, these are kind of newer, if you will, to a lot of the did-based community or the did web community. Okay, next slide. Benefit 7, did WebS identifiers are more secure, but also add useful new capabilities. I think we kind of said that beyond did web. Okay, next slide. Did WebS identifiers are portable. So there's no single blockchain or anything like that you're locked into. there's no single platform. Truly, Glyph's mandate is this concept of identity that's cross-border, right? It's global, and so these identifiers are very useful in a context where you may have, cross-border transactions, cross-platform transactions, cross-chain plans transactions. So you could use carry and did WebS based identifiers for on-chain, off-chain transactions and things like that. Okay, next. And yeah, if you want more information, there's the spec there, Trust over IP. It started under the Technology Stack Working Group. It's now under the Carry working group within Trust over IP. Our reference implementation is at Hyperledger Labs under did WebS Resolver. And yeah, we had some past presentations at IIW, and Marcus Sabadello had done an integration with the Universal Resolver. And that's it. Thank you. Oh, there is one more. Sorry about that. Let's see. Is this?
I think this was my slide.
Okay.
Yeah, we'll go to.
I'll just talk to that. Don't. Let's just move on to the demo. I can just talk to it. Let's move on to the demo. I'll share, and I can just talk to that. Yeah. Okay, so let me share my screen by doing this. Okay. All right, can everybody see the did WebS spec here? Okay, then we're on the right screen. So I just wanted to show everyone, first of all, this is the spec, did WebS spec. This is what, I was working to. And before I begin, I'd also like to just say thanks to both Glyph and Switchcord for the opportunity to do this work. It was a really fun project to do. And, I think it's really cool to have an implementation of did WebS actually live, in production out in the wild. So, in that sense, I think mission accomplished. So what I'm going to do here is two parts to this demo. One is I'm going to run a local version of Switchcord on my machine that does things the old way, that's did web based, so you can kind of see how it worked. Then I'm going to switch over to a staging environment that's hosted by Switchcord that I'm not going to do the demo in production, but I'll do it in the staging environment. So you'll see kind of what it's like, in the wild with did WebS. So let's start with that. So I have this instance of Switchcord running in my local environment here. And what I want to do is I want to sign up for this as a songwriter, for example. So I'm going to just log in as, Alice. It doesn't really matter what I put in here, at songwriter.com. And that's going to send out one of those classic, register emails, which I can capture in here. And I've got this, kind of, again, classic complete my registration. I'm going to open this in a new tab. And I'll fill in the information for Alice here. She's, Alice Brown, whatever, password. All right, so then I immediately move into the personalize your account bit where I can, change my handle, and it walks me through the various benefits that I get from using Switchcord. And finally, I come to this identity screen here. You would have seen a version of this essentially in the slides that Cole showed. So I'm going to jump to the actual My Identity page, and you'll notice that it includes the did. So this is a did web. And we're going to just resolve this did web according to the did web method rules. So I'm going to paste this in up here. And according to the did web method rules, the way I resolve this is I delete the prefix. I decode any port colons that I need. And I replace all of the remaining colons with slashes to indicate the path. And then to get the did document, it's always a did.json. So this should, for people familiar with did web, this should, this is how you resolve a did web. And what I'm looking for is the did document. So I get the did document indeed. This is a, very basic, simple did web, did document. This is what switchcord generated originally when they were focused on just using did web. This should look familiar to people. Again, it's very basic, but it's a valid did web, did document. Any questions on this so far?
Nope.
Okay, so now I'm going to switch over to this instance of this is running in the switchcord staging environment, and we've got the did WebS capabilities turned on here. So I'm going to go through the same flow. I'm going to sign up. This time I'll be, Bob. I need to use a correct domain here. I'll just use my testing one. So and I should be able to pick that up here in my Mailinator account. Yep. And I'm going to click through to the complete my information page here. Now I'm going to click this next. I'm just going to point something out. When I did this first, it was very quick. All that was happening is switchcord on the switchcord backend was generating its own unique identifier for Alice, which is like a UUID basically, and generating the did. So it was very fast. In this case, because we're doing did WebS, Bob needs access to a Carria agent, which is being generously hosted by Roots ID. And so there is some communication back and forth, and then there's some cryptography that has to happen that requires, a little bit of time. So there's a little bit of a hiccup here. It's what this is how you know it's working, is it takes just a second. So now we've got the same set of screens. I'm going to walk through these. And of course, what we're looking for now is instead of a did web identifier, we want to see a did WebS identifier. Sure enough, there we've got it, did WebS. And when we say that a did WebS is fully backwards compatible, this is what we mean by this. If I want to imagine that this is just a did web and I don't know anything about, anything about Carrie or anything, and I've got logic built into my system to resolve a did web, I can resolve this just like I would a did web. So I'm going to go through the same procedure. I'm going to delete the prefix. I'm going to look for any encoded or percent encoded port indicators, of which there are none. Then I'm going to go and I'm going to replace all of the colons with slashes. And I'm looking for a did document, so I'm just going to look for my did.json. And sure enough, there it is. So if I know nothing about Carrie, I can just resolve this like the did web. I don't know anything about anything, right? Like I just do this and there it is. Now this did document is has more optional fields filled in that are required by the did WebS spec. So the did WebS spec takes the did web spec and then says, also, these other fields are required in the did WebS spec that wouldn't necessarily be required in did web. For example, Lance pointed this out, the also known as. So as I just pointed out, you can essentially resolve this did as did web, but you also could resolve this as did carry. And of course, this identifier here, this is the AID, the autonomic identifier right here. And again, for people in carry land, this would be super familiar. They would look at this and probably immediately just recognize this is an AID. And it's this AID that allows the linking of the original inception, key data with whatever subsequent rotation or other events might occur, and creates the ability to have this kind of blockchain or chain of events that are cryptographically tied together. So, I mean, this is great. This is just did web, but the thing we really want to do is we want to be able to get this verification metadata in the carry.caesar stream. So that's what we want to do here. We're going to go ahead and get this. This will be a stream of Caesar encoded data. And there it is. And I can just download it to my machine here. And let's see, I can go to my Finder. Here it is. I can open this with my text editor. And you'll see this carry encoded, this Caesar encoded string. It's of course very dense and compact, and this is very much, Caesar. It's meant to be a compact encoding scheme. But if I were to take this, copy it, and for the sake of sort of human readability, throw it into an IDE, you would see that it looks a heck of a lot like JSON. In fact, this is media type application/Caesar, which is a registered media type. And in rudimentary terms, think of each of these brackets as events that are occurring, and then what's following is the signature. And this is what we mean by kind of the linked chain of events. You can sort of start and you can read down and you can see all of the various events that have happened and the valid signatures proving that it was derived from the previous event. So I mean, I think that's it. Am I missing something? Anybody? Lance, do you want to comment on that or anything? Should anybody have any comments? But this is basically it. So like now, SwitchCord can do this, and SwitchCord has this ability to have these more secure identifiers for its songwriters and publishers and whatnot. So there you go. Pass.
Awesome.
My only comment is that it's I love the way you present that, because it really does show kind of how close this is to a did web experience, while also introducing carry. And so yeah, I think that's a fantastic presentation.
Thanks.
Indeed. Thank you. Thank you all. Do you guys want to, we've got 10 minutes. Is there anything you want to do to wrap it up, or do you want to take time for questions?
Got any questions for anybody, I guess?
I mean, it was a whirlwind tour, mini tutorial on the music industry, mini tutorial on carry. I learned how to resolve a did manually. This is incredible. What the key objectives in sort of migrating, was it security first and then sort of persistency or interoperability? What was the main factor in going to this migration?
From SwitchCord and the business angle, it is being able to have interoperability and not own these identities. Everyone's tried to build a database of who is who owns what, who has the right to do what. It's just the way the music industry operates. Anytime that happens, you have a bunch of stakeholders get together and say, okay, we're going to build the one database to rule them all. And then they build this database. And then it always falls apart because of financing and governance issues, because the music industry is very paranoid. You've got intermediaries that do a lot of licensing on behalf of other people. And the database that they've built over 50 years, they think is their big asset, the thing they got to protect, when it's just a tool. They should be using other tools, better tools. So anyway, they get concerned anytime one person comes along and says one consortium comes along and says, we're going to build the Holy Grail. Everyone gets freaked out because they think, whoa, does that mean people won't come to us for licensing purposes? And so anything building that is kind of dead on arrival. And so my theory for years has been, okay, don't build a database. Like, don't do it. Just build these little nested databases of, you know, an individual, an organization. And then you can think of a copyright identity as a composite of identities of the individuals and organizations that either have the right to own or administer it. And we can model it in through the legal contracts. That's a separate discussion. But so, yeah, like I can't have switchcord with a did web only framework where like it's on our server. And let's say we go out of business, there goes all those identities, you know, like they're not really portable. And that's us building a central database. And that's never been my goal. So I've always wanted to transition us to something else. You know, I didn't want to do a single blockchain based implementation. I discovered Carry in 2021, early in 2021. And like, that was the aha moment for me. That's what I was looking for. Also, some of these identities may need to reside on, say, a big music publisher's, like the did.json file, may need to reside on their server. You know, Sony Music Publishing may not want a did web s switchcord or did web switchcord. They may want did web Sony Music Publishing. So this gives us the flexibility to have those interoperating and still use switchcord as this central sort of deal platform where your identity can come in and do things. So that was the business case, was you can't hold these things hostage, and did web s through Carry is a way to get around it.
So you've got your oh, sorry, go ahead.
I was just going to add that from an implementation point of view, you know, we've had to kind of take a half measure here just because of the reality of, you know, the way things are right now. Like no switchcord songwriters have like a Carry wallet or anything like this, right? So at this point, you know, switchcord is the custodian for that key material. But that's the point, is Cole wants the ability to be able to eventually, you know, not be that case. And this puts him in a position where he can eventually make that be true.
Yeah, like the music industry, especially music publishing, is about 20 years behind the times on technology. So I can't just come out and say what we're actually doing here and like require people to use a Carry agent or a Chrome browser. Like, it's not going to work. So we're realistic. We take baby steps.
Right. Okay. Excellent. So I was going to say that it's making your platform interoperable and your users, giving them freedom as well to hop between platforms eventually.
Yeah, exactly. Yeah, what Truman just said about Blue Sky, it's the same approach. Like, I want a world where a Blue Sky PLC did can log into switchcord and sign a split sheet, or you know, like that's what we're going for.
Right. Excellent. Nico, hand up. Or Nicholas.
Hey guys.
Nicola.
Yeah, great to see this in action yet again, Jonathan. It's good stuff. It's just as impressive as it was at IAW. Cole, it's good to see you. In the same spirit of the question, I think Eric was asking before, right? In terms of, you know, why you want to do this. Have you seen an understanding from the industry as to how important it is to have portable DIDs and portable identities, and therefore associated metadata, signed data, right? And if like how basically have you seen the reception of this sort of approach, right, from people that may not understand it?
Yeah, so the music industry is funny. This new lingo that they talk about, it's called trust and safety, and it stems from a major problem in the music industry, which is known as streaming fraud. You can classify streaming fraud in two buckets. You can have what we focus on content fraud. So that's on getting music and information into the supply chain. And then you can have post supply chain. So on the consumption side, you can have what's more commonly called streaming fraud. So that's using bots, using fake accounts to juice streaming numbers. And then most of the streaming economics are a common royalty pool. So you can game the system and make a ton of money. Like you're just stealing money from others. So two ways to do it. That whole thing gets lumped in with trust and safety. But a problem that the music industry has is there's no identity system and there's very poor identity verification mechanisms. So what happens is a lot of people take music. What's happening all the time now is music that goes viral on social media like TikTok. You can rip the audio and then you can go to one of the digital distributors. So Spotify and all of them, they don't work directly with independent songwriters, recording artists. They make you go through a distributor. just like any supply chain. So you go to someone like TuneCore or CD Baby, there's all these distributors where I, as the bad actor that just ripped the audio from TikTok, I then upload it through them claiming I own it. And then it goes on the streaming service. And so now I'm getting the royalties associated with those songs. Once the true owner finds out, they have to send like a takedown notice and all this to get the royalties changed on the back end to send to them. So that's content fraud. And when I explain what we're doing, and I explain how, yeah, you can have a verified individual or organizational identity through an LEI and a BLEI, and then you can have what we call contract credentials. It's the, modeling the contractual authorization you have. That's how you stop content fraud. You just put a little filter on the pipe that people are trying to put into the supply chain. It says, okay, present, sign it with your verified identity, sign the data, or present a credential that says, I have the right to upload this. And that is resonating. Everyone's kind of, the light bulb is now going off, but I have to speak in their language. I can't talk about I can't speak in this language at all. I have to speak in terms of like pipes and filters and trust and safety.
Right. And these sort of concepts they're familiar with, right? It seems to me that you're approaching this from the right angle, and maybe it's as simple as just explaining that you can determine ultimate beneficial ownership of music IP.
Yeah,
that's
exactly.
Powerful.
Yeah, and we also built it this way because like Switchcord is in itself a proof of concept. Like the things that I've been working on for many years are not limited to music. These are any commercial transaction. So any commercial transaction, if it's done online, you need a dual root of trust. You need a cryptographic root of trust, and you need a legal root of trust. The vast majority of cases, your legal root of trust is going to be a legal contract. Like it'd be great if the Constitution and statutes had, decentralized identifiers and digital signatures. It's not the way it works, but we can do it with contractual roots of trust. So that's what you just saw, is marrying those two worlds. And that's kind of what we're bringing to anything. That's the long-term goal here.
We're at the top of the hour. So I have one question, but first I wanted to say thank you for your presentation. It was fantastic. Lots of great information, really appreciated. And so this would then close our ecosystem and governance working group meeting. And just in case, if anyone sticks around, my question was, you talked about portability of the DID. And I'm just wondering what needs to come, what are some of the pieces that one would need to build in this ecosystem to enable portability of the DID as a future object?
I can speak to it a little bit. I mean, the tools are all there. So this was built using the Signify protocol and the Signify TS library, which is out there. A lot of people in this call have actually worked on that library. And the Caria agent is also, Caria is out as an open source project. So the tools are there. What would need to happen really is that these, the songwriters, the publishing agencies would need to have, carry enabled wallets. So either on a device or in the browser. And once you have, and both of these again exist. So like it would just require the social adoption of these things to happen. And then it's just, they become migratable essentially.
Right. So it's a cultural, the tooling is there.
Correct.
There's
Yes.
the cultural acceptance of it, and somebody else making another carry wallet that it could then be moved into, something like that.
Yeah, but again, like all of those pieces absolutely exist. And there's the Glyph institutional wallet. There's a whole bunch of things that are out there that would support this kind of thing. It just requires people to start using them.
Excellent. Okay.
Yeah, please feel free to leave or stay. I don't know about the presenting team, if you guys are here to stay, but if there are any questions, are you happy to stick around a little bit, or do you have meetings to run to?
I'm good.
Yeah, I'm fine for as long as we need.
Just very quickly, is the people that you talk to, are they familiar with Glyph and LEIs? Because I mean, if they're already doing their financial reporting, do most of them already have LEIs?
No, most people in the music industry don't know what an LEI is. So
But if they, They may not, so because I asked this question, because I've sometimes gone into presentations and done a quick lookup. I'm like, oh, you already got an LEI, and they don't know it, but somebody somewhere in the hierarchy of the organization has registered an LEI.
Yeah,
It's
some of the
usually-
the major players do, like Universal Music Publishing. Carly, you can probably speak to this more than me, but anyone doing financial transactions is probably going to have one. But the vast majority of people, at least that we talk to right now, do not.
Yeah, you'll find that perhaps their treasury departments needed to apply for one because of certain financial activity that they are involved in, hedging or anything like that, financial products that they invest in.
Right. Yeah. Okay. Now I am surprised when some of the companies I talk to have already got LEIs, but they don't know it, or at least down the
In a
food
way,
chain they
it's
don't.
helpful, taking people from nothing to something, because I don't know, sometimes it's easier because you can leapfrog some of these intermediate steps.
Yeah.
So I've been talking with Bloomberg and Rapid LEI on workflows for that, potentially just a organizational identity verification product, and then Finima and Provenant on the VLEI side too.
Okay. Any other questions? Going once. Twice. Oh, have you got the governance? Have you got the? I know that you're working on the governance. Cole, the whole governance for Switchcord as a platform. Are you sort of progressing on that?
That one's kind of on hold just because we need more, there's so many players. The game theory here is a bit tricky,
Right.
but so from our core platform that we presented today, it's not quite as important, but we have had a lot of interest in pure identity verification products for performing rights organizations, distributors. Now you're really getting into it. Now you're looking at, okay, do we have trust registries? Do we have that's what we need it. And so obviously Scott's going to be helping us and other people are going to help us with that. But
Right.
yeah, exactly. Drum and traction first.
Mhm.
But yeah, they're two separate products. Our core platform is separate from just a pure play sort of music focused identity verification product, and we can spin up as needed.
Right. Okay. All right. Shall I call it a day? Thank you very much. Wonderful.
Good.
Thanks, everyone.
Thanks, everyone.
Thank you, everyone.
Bye.
We'll see you
Bye.
next
Thanks. Really great stuff.
Yeah.
You bet. Thanks all.
All right. Cheers. Thank you.